and corrected it flat. Yes?
If that makes you happy.
Me, you were the one laughing, Sunshine.
That horse...
Stutter for me. That's correct. You're making it horizontal. That would be flat.
Okay.
Yes, so you've corrected your dip that you think is a sphere dip correction to be flat then.
See, this is the point you get...
Sorry, so that would be a yes. You've corrected it flat.
We've had to make it flat.
That's right, we've had to make it flat. How do you acquire an elevation angle from a curved adjacent? Can you answer that, please?
You just said it. It doesn't give you 90 degrees. That's why we have a dip correction.
Correcting it flat.
Exactly.
It's exactly what? Correcting it flat.
Correct it. You keep saying it and not realizing that you're making the exact point.
The Earth's flat, and any preconceived notions of sphericity will be corrected, because if they weren't, you wouldn't get 90 degrees below the star. Is that laugh again? If it makes you happy, you can laugh at your own loss. Correct it and make it horizontal. And now you're telling me that that correction you just described to make it horizontal isn't flat? Yeah, it is.
That horse...
Stutter for me. That's correct. You're making it horizontal. That would be flat.
Okay.
Yes, so you've corrected your dip that you think is a sphere dip correction to be flat then.
See, this is the point you get...
Sorry, so that would be a yes. You've corrected it flat.
We've had to make it flat because...
That's right, we've had to make it flat. To do celestial navigation, it's got to be flat. And you, the globe-believing Fundy, have just made it flat with this correction. So we're all in agreement, it's got to be flat. You've just made it so, correct?
The celestial horizon has to...
So that's a yes. We've made it flat. You have just made it flat. Yes is the response I'm looking for, an affirmation of what you just declared when you made your correction and corrected it flat. Yes? Laugh it up. That's right, it's flat. Earth's flat. That laugh is because you understand and I understand that your correction just made this maths possible, and possible because Earth's flat. That's how you corrected it, didn't you? Laugh again.
So Nathan...
So stutter about how you're not going to concede the thing you've just described, the correction to horizontal, making it flat. You still haven't said yes, you've just laughed.
Because you're wrong.
I'm wrong? You were the one that corrected it to be horizontal. I'm wrong. I confirmed what you told us.
And you got it backwards.
So when you said you corrected it to horizontal, that was backwards, was it? We're actually correcting it to be curved, are we?
The Earth was flat.
Sorry, we're correcting it.
From the curvature
Sorry,
of the Earth
you're not
to get to a
listening.
flat
I got it backwards. I heard that. So I'm clarifying what you meant by that. We're actually correcting it to be curved like your sphere Earth you believe the ground is. We've corrected it curved, right? Or did we correct it flat?
We went to the flat.
Flat? So that's a yes then? Rather than I've got it backwards, we definitely did make Earth flat to do this.
The surface of the Earth is the
Made it
celestial
flat.
horizon, the surface
We
of the
made it
Earth.
flat, right? Flat.
So, because some...
So you're not going to concede it because it's too painful? You've made this correction, we've got Earth flat, we've got our 90 below the star, your sphere Earth's been corrected flat.
Because it's on a flat table. Is that...
So we're talking about flat tables now rather than you conceding that you've made the entire world flat with your correction. You're just not conceding that, even though it's what you described, and told me that I've got it backwards and we've clarified we're not making it curved to do this trig, we're making it flat.
Has anyone posted that...
Is anybody ignoring me completely? That'll be you. Yes, somebody's ignoring me completely. You've made Earth flat with this correction. You can't just seem to say yes. That's right, I made Earth flat with this correction. You want to just confirm that's what you've done?
I went to the celestial horizon, which is flat.
You seem to be quivering in your voice. Do I scare you? Just still looking for the same affirmation of your correction you've just made. Flat, right?
The horizon mirror points to the visible horizon, not a celestial horizon. And dip and
And that's what you have to correct away from it. That's exactly it. The horizon mirror points at the visible horizon, which is below the celestial horizon. So you have to correct horizontal.
It corrects the The dip and height of void correction corrects the vertex to the water, the surface of the water underneath the boat. The horizon mirror on the sextant points to the visible horizon. You create
geometric horizon, by the way.
You create a 90-degree right angle at the observer and a 90-degree right angle at the GP of the celestial body. You're talking completely utter rubbish.
That is correct.
What you're claiming, I know what you're claiming with your straight line off out in the middle of nowhere. You don't seem to realise that that won't work on your sphere, because that straight line won't match the distances that it will cover across the surface of the sphere. Your
It actually does, because I've graphed it.
No, it doesn't. It doesn't. What you're trying to do is create circles of equal altitude, right, which are 2D onto a sphere. You can't do that.
Yep, and I've done that. I've actually drawn it on an actual sphere.
Show the celestial horizon mirror on the sextant. Show it.
Why are you laughing?
That's why you do a correction.
Why are
You're
you
not
laughing?
doing the celestial horizon. That's why you do a correction.
Sorry, and we're correcting to the celestial horizon. That's something you're measuring with the sextant.
He said it's completely
Stop.
wrong.
Hello?
He said it's
Hello?
completely-
Hello? The question you got was, that's if you're claiming to be corrected for. What we are citing with the sextant then, you laughed. Is that not correct?
You're not citing on the celestial horizon.
Oh.
You're citing on the visible horizon.
Well, that's a problem for your argument.
Correct.
Sorry, you
correct
laughed.
the celestial
Sorry,
horizon.
do you want to stop
That's why the
talking? Sorry, when your argument fails, doesn't mean that you need to babble incessantly through the devastating point being reiterated to you. That's a big problem for your argument then, isn't it? You understand, or did you just want to laugh again? At your loss, that is. That's what you laughed at. You realise that you laughed because you lost?
If that makes you happy.
Me, you were the one laughing, Sunshine, at your own loss. So we're not citing the celestial horizon in the sextant then. That's not what we're correcting for when you made it flat. You also laughed.
You're correcting it too. You're
And
correcting
now
it.
interrupted because you're detecting that I'm going to point out that the correction made it flat. You laughed at that too. Do you want to tell me that that makes me happy? It seems like you're projecting quite a lot of your own amusement at your own losses onto me. I didn't laugh when asked about the correction to flat that you made. You did. If it makes you happy correcting it to flat, we can carry on after the correction to be flat to get 90 degrees to do triangulation. Something you lied about in your opening gambit here. Needing that 90.
Okay, so triangulation.
No, okay. Again, you tried to tell me it was okay last time I summarised your lies about needing 90. And now we're correcting to make it flat so you can get 90, the one you lied about when you first got here. If it makes you happy to lie about needing 90 and then explaining how you correct Earth flat to get 90, maybe you can laugh for us again. If it makes you happy to laugh about your losses, which you do.
Okay,
So, in order to acquire this 90 degree, we're going to need a flat plane. It's going to have to be flat to have this 90 degree angle below the star. Earth must be flat to do this. Now, if you want to disagree, we'd like to know how you acquire an elevation angle if the surface beneath your feet's curving away from you, because that won't give you 90 degree to the star. How do you acquire an elevation angle from a curved adjacent? Can you answer that, please?
You just said it. It doesn't give you 90 degrees. That's why we have a dip correction.
Correcting it flat.
Exactly. Because
It's exactly what? Correcting it flat.
correct it. You keep saying it and like not realizing that you're making the exact point.
The Earth's flat, and any preconceived notions of sphericity will be corrected, because if they weren't, you wouldn't get 90 degree below the star. So in conclusion, Earth must be flat, and this globe believer must correct his fundy sphere belief flat in order for this to work.
You don't see the total contradiction in what you're saying there, Nathan, do you?
No, I see a right angle triangle presented by you with 90 degree being the only way to do the trig. And you've told me that you've made a correction from your fundy sphere belief, which isn't being cited in the sextant, to make it flat. That's what you told me.
Why would we have to make it flat?
To do trig. To get 90 below the star.
Let's talk about it.
Let's establish that we've got a flat plane beneath our feet to do that. And if we haven't, you're going to make it so by correcting it to be so. We know, you told us. Why would we do that? To get around. To triangulate our position. That's why we do it. You just need a flat plane to do it.
Let's talk about that supposed triangulation that you're doing.
It's on your diagram that you posted.
Elevation.
Sorry, we're back to your straw man that this isn't how celestial navigation's done. It's just our claim. We already established that it's not our claim. It's just how it's done.
If it's no.
No. Yes. That's definitely how it's done. We definitely do trig with right-angled triangles to establish our position by way of triangulation. That is how it's done. This right-angled diagram that you posted is a fairly reasonable description of measuring an angle to a celestial object and then getting 90 degrees below it. And what do you know? We have definitely in your diagram got a flat plane for this triangle. That's how it's done. Fact. Don't have to like it.
If it's done, then why doesn't the math work? I'm showing you...
Sorry, the math doesn't work. You think that trig and triangulation isn't working and they don't have sextants on aeroplanes just in case because it does work. You think it doesn't.
So you
think it doesn't work. They don't put the sextants on aeroplanes just as a backup because you think it doesn't work. Is that laugh again? If it makes you happy, you can laugh at your own loss. You've lost, fuckwit. That's right, they do definitely use sextants to figure out their location because it definitely does work, and it works with right-angled triangles off flat planes.
Not use right-angled triangles.
Well, why did you post one?
Because I'm showing your version of it. And
my version, or just celestial navigation straw man attempted for the third time? It's not my version. I've never done this, ever. Why would you presume that the very well-documented process of celestial navigation is mine? It's not. This is just how it's done. Stop making it mine so you can try and attack it like it's wrong when it's being done the world over and they carry sextants on aeroplanes so they can achieve this method with flat planes. Obviously, they're using a bubble sextant on a plane because they can still get 90 if everything's flat and parallel to their position in the air. You couldn't do that if it wasn't flat either. But you're telling me it's my version and my version's wrong when it's definitely not. It's just celestial navigation. You already conceded it, but we know you're a lying pig, so you're going to strawman us that it's our version and it doesn't work when it definitely does.
Okay, so...
Okay. No, not okay. You seem to be positioning this celestial navigation method like it's mine and doesn't work when it isn't and it does.